Today we are going to see a topic about power dividers. So this is a topic from the unit 4 about active, microwave, active and passive devices. So power dividers, in power divider the main important thing is to avoid the reflected power. So it should satisfy the maximum power transfer theory. And according to theory, it states that impedance of the load should be the complex conjugate of the impedance when you are seeing from the load end when the load is not connected. So this is also called as matching of port. And also in this maximum, to transfer a maximum power to the output port, the network should not dissipate the power, and this property is called as lossless property. Another issue is the isolation. So the output port, in output port, there that is any unwanted signals from the output should not go to the output line. So these are the important characteristics of an power divider. And the symbol, that is a symbol T junction power divider, is mainly used for power division and power combining, and it is implemented in the transmission line medium. So here we are going to see about two examples. The one is the E plane T and H plane T, and both E plane T and H plane T cannot be matched simultaneously, and the resistive dividers are used which can be matched all the port. However, we cannot achieve the isolation. Whereas when we are using Wilkinson power divider, we can match all the port, and also we obtain the isolation. So first we can see about the E plane T. So E plane T is the intersection of three waveguides. So it will be in the form of an alphabet T, and here the two ports, port 1 and 2 are called as collinear arms, and port 3 is called as E arm. And this T junction is mainly used for power combining or power division. So you can see the representation, or it will be given in the figure. That is the E plane T. The port 1 and 2 is the collinear arm, and port 3 is the side arm or E arm. And the figure shown below is the real-time image of the E plane T. So E plane T is a voltage or a series junction symmetrical about the central arm, and the signal to be split will be fed in it. And in the dominant mode TE10 is made to propagate to the port 3, and the output from the port 1 and 2 will be the same amplitude, but the phase is shifted by with respect to each other. And the E plane T is symmetrical about the central arm. However, the power coming from the out from the port 3 is proportional to the difference between power entering from 1 and 2. If the fields of the opposite polarity is given to the arms 1 and 2, the field in the symmetrical arms are added. So this is about the working about the E plane T. Now we can see the analysis of E plane T. So for the analysis of E plane T, we are using 3-port junction S matrix. 3-port junction, we are using the S matrix of the order 3 cross 3. So 3 cross 3 matrix is written as S is equal to S11, S12, S13, S21, S22, S23, S31, S32 and S33. And the scattering coefficients is S23 will be equal to minus S13. This is because the wave coming from port 1 and 2 of the collinear arm will be opposite in phase, but same in magnitude. So the negative sign indicates the difference in the phase, that is the phase difference. And the port 3 is a perfectly matched port. So the S coefficient S33 is equal to 0. And also by using symmetrical property, that is Sij is equal to Sji, we can write for this E plane T S12 is equal to S21, S13 is equal to 31, S23 is equal to 32. And when you substitute all these properties in the S matrix, you will be getting S is equal to S11, S12, S13, S12, S22, S minus S13, S13 minus S13 and 0. And by applying the unitary property, that is S into conjugate of S will be equal to identity matrix. So for 3 cross 3 matrix, we are writing the S, and from previous equation we are writing the S. Next the conjugate of S, next is the identity matrix. So using this, we are multiplying the rows and columns. First step, we are multiplying the row 1 and column 1. So we will be getting S11 modulus of S11 the whole square plus modulus of S12 the whole square plus modulus of S13 the whole square is equal to 0. Similarly, the row 2, column 2, row 3, column 3, and R3 and C1. So we will be getting the equation from 4.19 to 4.22. So from 4.119 and 4.20 we can write the scattering coefficient S11 is equal to S22, and also S13 from equation 4.21 we can write S13 is equal to 1 by root 2, and the equation 4.22 we can write S13 into S11 conjugate minus S12 conjugate is equal to 0. So but this scattering coefficient S13 is not equal to 0. So since it is not equal to 0, the term inside the bracket is, that is S11 conjugate minus S12 conjugate will be equal to 0. So using that we are solving, we will be getting S11 conjugate is equal to S12 conjugate is equal to S11 is equal to S12 which is equal to S22. We will be getting the equation 4.25. So taking the values from the equation 4.23, 4.24 to 4.25 in the equation 4.19, we will be getting S11 is equal to S12. Similarly, when we substitute the equation from 4.24 to 4.26 in the scattering matrix equation 4.18, we will be getting the scattering matrix S as 1 by 2, 1 by 2, 1 by root 2, 1 by 2, 1 by 2, 1 by root 2, 1 by 2 minus 1 by 2 into 0. So now we are writing the coefficients in terms of coefficient. We are writing matrix as B is equal to S into A. So for 3 cross 3 port junction B1, B2, B3 will be equal to, yes, we are substituting the value of X from the previous equation, next A1 and to A2. So when we do the multiplication, we will be getting the coefficient B1, B2 and B3 from the equation 4.28 to 4.30. So next we are considering 3 cases. That is the first case, the input is given to the port 3 and there is no output at port 1 and 2. In that condition A3 is not equal to 0 and A1 and A2 will be equal to 0. And from the equation 4.23 we will be getting B1 is equal to 1 by root 2 A3. From 4.29 we will be getting B2 is equal to minus 1 by root 2 A3. Similarly from equation 4.30 we will be getting B3 is equal to 0. Similarly the case 2, we are giving the input at port 1 and 2 and no output at port 3. We will be getting the equation coefficient from B1 to B1, B2 and B3. Similarly the case 3, where the input is given to port 1 and no input at port 2 and 3. In that condition A1 will be not equal to 0, A3 and A2 will be equal to 0. So for that condition we are getting the 3 coefficients B1, B2 and B3. So these 3 conditions are used to analyze the coefficients of the E-plane T. So next is the H-plane T. So H-plane T is formed by cutting a rectangular slot along the width of the main waveguide and attaching with another waveguide side arm called the H-plane T. And the port 1 and 2 of the main waveguide are called as collinear ports, and port 3 is the H-arm or side arm. When the wave we are giving to the port 3, it will be split into two equal in phase waves in 2 arms, that is port 1 and 2. And if you are giving 2 waves, if 2 waves are fed from 2 side arms 1 and 2, they will be added in the accelerator arm 3. So figure shows the H-plane T. You can see this port 1, 2 and 3, which is represented. In that port 3 is the side arm, that is called as a H-arm, and port 1 and 2 is the collinear arm. So you can see all the representation, real-time representation of this H-plane T. So now the analysis of H-plane T. So similarly, similar to E-plane T, this H-plane T is also a 3-port junction. So we are writing the S matrix of the order 3 cross 3 as S is equal to S11, S12, S13, S21, S22, S23, S31, S32 and 33. So because of the symmetry, plane of symmetry of the junction, the scattering coefficient can be written as S23 is equal to S13. And also if the port 3 is perfectly matched to the junction, S33 will be equal to 0. And by using symmetric property, Sij is equal to Sji, that is S11 will be equal to S21, S13 is equal to 31, S23 is equal to 32 and 31. So using the above properties, we will be getting the scattering matrix S is equal to S11, S12, S13, S12, S22, S13, S13, S13 and 0. So from the unitary property, that is S into S conjugate is equal to identity matrix. So we are substituting the matrix from the previous equation and writing the identity matrix for 3 cross 3. And next step, we are multiplying the rows and similar to the E-plane T, we are multiplying the rows and columns. So first we are multiplying the row 1 and column 1. So when we are multiplying R1 and C1, we will be getting the equation as modulus of S11 the whole square plus modulus of S12 the whole square plus modulus of S13 whole square is equal to 1. Similarly, we will be getting the equation for R2, C2, R2, C3, R3 and C4 from equation 4.435 to 4.38. Also from the equation 4.35 and 4.36, we will be getting S11 is equal to S22. And also when you solve the equation 4.37, we will be getting S13 is equal to 1 by root 2. And from 4.38 equation, we will be getting S13 is equal to S11 conjugate plus S12 conjugate will be equal to 0. And since S13 is not equal to 0, S11 conjugate plus S12 conjugate is equal to 0. When we solve, we will be getting S11 conjugate is equal to minus S12 conjugate, S11 is equal to minus S12, and S12 is equal to minus S11. And also to find the coefficient, we know that B is equal to S into A, that is a coefficient B1, B2, B3 is equal to scattering matrix into A1, A2 and A3. So when we solve this scattering matrix, we will be getting the equations for the coefficient B1, B2 and B3. B1 is equal to 1 by 2 A1 minus 1 by 2 A2 plus 1 by 2 into A3. Similarly B2, B2 and B3. So here we are considering 3 cases. So first case, the input is given to the port 3 and no input is at the port 1 and 2, and A3 is equal to, for this condition A3 will be equal to 0, not equal to 0, A1 and A2 is equal to 0. So from the equation 4.46 we can we will be getting B1 is equal to 1 by root 2 into A. 4.47 we will be getting B2 is equal to 1 by root 2 into A3, and B3 is equal to 0. So 3 coefficient B1, B2 and B3. So hence the power coming out from the port 1 and 2 is 3 dB down with respect to the input port at port 3. Hence this H-plane T is also called as 3 dB splitter. Similarly, second case, the input is given to 1 and 2 and no input at the port 3. So A3 will be equal to 0, A1 and A2 will be equal to A. So here also we will be getting the 3 conditions. First when we are using using the substituting this condition 4.46, we will be getting B1 is equal to 0. When we substitute this condition in 4.47, we will be getting B2 is equal to 0. Similarly, when we substitute this condition 4.48, we will be getting B3 is equal to A by root 2 plus 1 A by root 2. So input at the port 3 is the addition of two input at port 1 and 2, and these are in phase. So these are the 2 cases for H-plane T. So in this class we have seen about the power dividers, 2 power dividers, that is E-plane and H-plane T. So we have seen the working principles of this 2 power dividers, and also the analysis by using scattering matrix. We have analyzed the scattering matrix for the E-plane and H-plane T. So this is for this class. So this is all for this class. Thank you.